So if we have a tumor that's spherical in shape, so we got a tumor, and pretend that's a sphere, right? You got something like this, and it has a radius. The radius of the tumor changes from 7 to 9. So it goes from a radius of 7 to a radius of 9. That means that our change in radius is 2 millimeters. Find the approximate change in volume. So they want the change in volume. Now we could calculate the volume of the two different spheres. In other words, you're going to have a small sphere with a radius of 7, and then another sphere with a radius of 9. But we want to use calculus and related rates of change. So the first thing we want to do is, because we want to know the change in volume, we start with the volume of a sphere, which is 4/3 pi r cubed. And then we take the derivative. Now, the derivative of the volume is with respect to r, right? Because v is dependent on r. Those are the only two real variables in the equation. So 4/3 pi, those are all constants. Those are just going to be 4/3 pi, and those stay here. And then I'm going to take the derivative of r cubed, which is really 3r squared dr, but I'm going to toss the 3 to the front, and then the r squared on the back end, and I'm just going to leave this dr thing here. The 3's cancel, so I get that the change in volume is equal to 4 pi r squared dr. So now, I just got to plug some stuff in. So to find the approximate change in volume, I'm going to say that dV is equal to 4 pi, and r should be 7, because we're starting at 7 and we're changing to 9. And by the way, this is an approximation. When we talk about change, we're talking about instantaneous change, and this was part of our related rate / instantaneous, linearization approximation process. So what I would do is, since we're going from 7 to 9, I'm going to assume that the radius should be 7. And then my change in r would be 2. Now this is 7 meters, and this is 2 meters. So really, my change in volume is going to be 4 times pi times, what's 7 squared?
49.
49, but remember I have meters squared, so it's 49 meters squared, and then times 2 meters. So when I'm done with all this stuff, I should have meters cubed, right? And we just plug it in the calculator to get the rest. So what I'm going to do then is I'm going to plug in, clear, 4 times pi times 49 times 2. And I get 1231. Well, A is 1200. Does that make sense?
Yeah.
Okay.